Hi everyone, welcome back to mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is a pure Mathematics 3 for May-June 2021, and the code is 9709/32. So let's move on to question number 1. Question number 1, solve the inequality absolute value or modulus of 2x minus 1 less than 3 times modulus of x plus 1. So from here, we will use the definition of the modulus function. Okay, so just for your information, modulus x is same as square root of x squared. Okay, so that is the definition for modulus function. Therefore, this will be changed to square root of 2x minus 1 squared is less than 3 times square root of x plus 1 squared. Okay, so to eliminate the square root, we need to square both sides. So by looking at the left hand side, the square and square root will be cancelled off. Then you'll be getting a quadratic equation or quadratic function. Then this square, you must bring it into the 3 and also the square root. So when we bring it into the square root, the square and square root will be cancelled off. Okay, that means you will be getting 2x minus 1 squared less than 3 square bracket x plus 1 squared. Then now, expand this quadratic expansion using quadratic formula, which is square of a plus b. Then you'll be getting a squared plus 2ab plus b squared. Okay, then from here, you will be getting square of 2x, which is 4x squared. Then 2ab, that means 2 times 2x times minus 1, that is negative 4x. Then square of minus 1 is plus 1. Less than 9 bracket square of x plus 1 using the quadratic expansion, you will be getting x squared plus 2x plus 1. Okay, so for the right hand side, just do the expansion. Multiply all the terms inside the bracket by 9. Then you will be getting 9x squared plus 18x plus 9. Then the left side will be 4x squared minus 4x plus 1. Okay, so from here, I will move all the terms to the right side because you have 9x squared, which is greater than 4x squared. So once I have moved, I will get 9x squared minus 4x squared is a 5x squared. 18x minus 4x, it will be plus 22x. And then the plus 1 move to the other side becomes minus, then you'll be getting plus 8. So all the terms are on the right side. That means when you read from right side, it's actually greater than 0. Okay, then from here, this quadratic inequality can be factorized into two linear factors. The first linear factor is 5x plus 4, and the second linear factor is going to be x plus 4. Then both are greater than 0. Now, to get the region of this, we need to sketch the graph of this quadratic function. So the coefficient for x squared is positive 5. That means this quadratic curve will have a minimum point. So now my minimum point will be, my graph will be in this shape, and then I will just let these two factors be 0. So the first factor, when I let it be 0, the x will be negative 4 over 5, and the second factor is negative 4, which means this is negative 4 over 5, and the left hand side one will be negative 4. Okay, so now for the final answer, we look at the the inequality sign here, which is greater than 0. So when greater than 0, we will accept the y values which is above the x-axis. So all this will be positive y values. So which means your final answer will be x less than negative 4, because all my regions will be less than towards the left hand side here and also towards the right side. So which means my answer will be x less than negative 4, or x is greater than, okay, I made a mistake, this is 2. Okay, this is 2 plus 2, so 2 plus 8, 2 times 4 is 8. Then this is going to be negative 2, or x is greater than negative 2 over 5. So this is the solution for question 1. Okay, now move on to question number 2. On a sketch of an argon diagram, shade the region whose points represent the complex numbers z, satisfying the inequalities modulus z plus 1 minus I less than equals to 1, and the argument of z minus 1 is less equals to 3 over 4. So for the first inequality, we have to express in z minus, okay, this will be minus 1 plus I, then I will get the circle. This is the circle equation with center negative 1, 1. Where do you get the negative 1, 1? Is basically here is negative 1 and this is 1i. Okay, so that is the center of the circle, and then the radius is going to be 1 here. Then now for the second inequality, argument of z minus 1 less equals to 3 over 4 pi. So argument is the angle. That means now we need to find the points as well, the reference points. So it will be z minus 1 plus 0i less equals to 3 over 4 pi. Okay, so from here we'll be getting a point with coordinates 1, 0. So here is the 1 and 0. Okay, so then now to sketch a graph or to sketch the argon diagram. So since your center is at minus 1, 1 and radius is 1, therefore, let's say I draw a circle first. Okay, let's say this is minus 1 and here is 1. This is the center. Radius is 1 means that this is going to be 2. Then here 0. Then touching all these points because the distance is 1. So that it is a radius. Radius is 1. So now I have to join all these points. Okay, so that's why I will draw the circle first. Okay, so the easiest way is I draw the circle and then I adjust my axis. Okay, so this is minus 1, 1. Here is going to be 1, 0, 1. Okay, so roughly this. So make sure you draw a smooth circle. Right, so now here is minus 1, this is 1, that means here is going to be 2. Then here is minus 2. Okay, this is imaginary of z, and here is the real part of z. Now, that is our circle. Less equals to 1 means that all the points inside the circle are on the circumference of the circle. Now, for the second inequality, our reference point is at 1, 0. So let's say here is 1 and 0. Okay, then now we need to draw the angle, which is 3 over 4 pi. So 3 over 4 pi, right? So it will be touching here because that is 135 degrees. Okay, let me check. It is less equals to, that means it will be solid line. Alright, so this is argument z minus 1 equals to 3 over 4 pi, because here is 3 over 4 pi. Okay, because it's less than equals to, that means it will be any points within this area, and it's also bounded by the circle, which means it's this shaded region. Okay, so that's the Argand diagram for this question. Okay, now for question number 3. The variables x and y satisfy the equation x equals to a times 3 to the power of negative y, where a is a constant. A. Explain why the graph against ln x is a straight line, and state the exact value of the gradient of the line. So now x equals to a bracket 3 power negative y. So it's mentioned y against ln x. That means now we have to take ln both sides. So ln x equals to ln of a bracket 3 power negative y. Okay, so we have a formula here. Ln xy equals to ln x plus ln y. Okay, when it is x times y there. So which means the a times 3 power negative y, you can split it into 2 ln. That would be ln a plus ln 3 to the power of negative y. And then now, based on this, it will be just y. That means I have to simplify the second term on the right side because you have the power there. So what to do is ln x to the power y, it will be y ln x. Then I will move down the power negative y. So which means this is going to be ln a plus negative y ln 3. Okay, that is my ln x. But then now I need to prove that it is a straight line when y against ln x. That means now I have to rearrange. So I will move this negative y ln 3 to the left side and the ln x to the right side. Okay, so that the y will be the subject. So I will get y ln 3 equals to negative ln x plus ln a. Then at last, the whole equation divided by ln 3. Then I will be getting y equals to negative ln x over ln 3 plus ln a over ln 3. Then from here, I will just write negative 1 over ln 3 times ln x plus ln a over ln 3. That is my y, which means this is my capital Y. Okay, y equals to mx plus c. Okay, so this is the straight line equation. Alright, so from here, you need to state the exact value of the gradient. So now obviously the gradient is our m, which is negative 1 over ln 3. Okay, so that's the solution of this question. Now it's given that the line intersects the y-axis at the point where y equals to 1.3. B. Calculate the value of y. Calculate the value of a, giving your answer correct to 2 decimal places. Okay, so now use back the equation that we have simplified just now, which is this: y equals to negative 1 over ln 3 times ln x plus ln a over ln 3. So now replace the y by 1.3, but since it intersects the y-axis, which means the x will be 0. Okay, ln x will be 0. Now because our x-axis is ln x, so now I will just write ln x equals to 0, y equals to 1.3. Okay, which means 1.3 is negative 1 over ln 3. The whole ln x will be replaced by 0, then plus ln a over ln 3. So from here, the first term on the right side will be 0. Then I will be getting 1.3 is ln a over ln 3. So to get the a, the ln 3 will be moved up. So ln a will be 1.3 ln 3. Therefore, my a, to eliminate the ln, I will have to take e both sides because we have a formula here. E ln A is A itself. Okay, so now if I take e ln A, e both sides, I will get e 1.3 ln 3. So the left hand side will be just A. Right hand side, when you count this, it will be 2 decimal places. So it will be 4.17. So that is the A value. Okay, question number 4. Using integration by parts, find the exact value of this inverse tangent, integration of inverse tangent half x dx. The x defined from 0 to 2. So now, to solve this integration is mentioned integration by parts. So just recall the integration by parts formula. It will be u dv over dx. dx equals to uv minus integrate v du over dx dx. And then if with limits, right, which is the definite integral, then you just add on the limits for all the terms on the right side. So now we know that we are able to differentiate inverse tangent function, okay, because we have a formula in the formula list. So formula list is d over dx inverse tangent x over a. Then this formula is a over a squared plus x squared. That means to differentiate, right, now when you look at here, from the u we get du dx. That means this must be u so that you can differentiate. So now from here I will write integrate 0 to 2 inverse tangent half x dx. Okay, it is same as integrates from 0 to 2 1 times inverse tangent x over 2 dx. Right, because for integration by parts, it must have two terms, u and dv dx. So the other term must be 1 in this case. So therefore, I will let my u be inverse tangent x over 2. That means now my du dx, right? So my du dx, just use the formula here and compare. Obviously, the a is 2. Therefore, I will be getting 2 over 2 squared plus x squared. And at last, you will be getting 2 over 4 plus x squared. That is my du dx. Now, then the dv dx will be 1. Okay, this is the 1. Then your v is to integrate 1 dx. That means you'll be getting x. Okay, so then the next step is just apply this integration by parts formula. It will be u v, so x inverse tangent x over 2 with limits 0 to 2 minus integrate from 0 to 2 v du dx. Okay, so I times x to the 2 over 4 plus x squared. Then I will be getting this expression. Okay, so then now next step is just to replace the x by the upper limit, which is a 2 first. So I will get 2 inverse tangent 2 over 2, which is 1, minus 0. Okay, and then minus, for this integration, that is 2x over 4 plus x squared dx. Now, for your information, we have to apply another formula here, which is integrate f prime x over fx dx. That is the ln of fx plus c. So why do we need to apply this? Because it is a quadratic function in the denominator. When you differentiate quadratic, it will be a linear function. So when I differentiate 4 plus x squared is exactly 2x, which is the left hand side in the formula here, okay, which is exactly the same form as in the formula. So I will be getting ln of denominator, which means now I will be getting, okay, so for the integration, I will be using this formula later on. So then when we solve the 2 inverse tangent 1, so the inverse tangent 1, it will be pi over 4. Okay, and now for the integration, it will be ln. of the denominator together with the limits 0 to 2. Then now, when I simplify, this is going to be pi over 2 minus, replace the x by 2 first. So 4 plus 2 squared, it will be 8. Okay, then minus, when the x is replaced by 0, then you'll be getting ln 4. So now, since we have 2 ln here, then I have to simplify using another formula, which is ln A minus ln B is going to be ln of A divided by B. Okay, then you will be getting pi over 2 minus ln of 8 divided by 4. Then at last you will be getting pi over 2 minus ln 2. So that is the exact value of the whole integration. Okay, now next question is number 5. The complex number u is given by u equals to 10 minus 4 square root 6i. Find 2 square roots of u, giving your answer in the form a plus bi, where a and b are real and exact. Okay, so now u equals to 10 minus 4 square root 6i. And now we need to find square roots. That means I let square root u be x minus yi. Okay, I choose a minus here because here is minus. The u is with the negative imaginary part. So if the u is positive imaginary part, then you can just let it be x plus yi. Alright, so then from here, I will just take square root of 10 minus 4 square root 6i equals to x minus yi. Then to eliminate the square root, you need to take square both sides. So the square and square root will be cancelled off from the left hand side, but then for the right hand side we have to do expansion. So it means that for the left hand side we get back the u, and for the right hand side you have to do the expansion for this quadratic. Then you'll be getting x squared minus 2xyi plus y squared I squared. So for your information, I squared is minus 1. That means this is minus 1. Okay, then I will simplify the real and imaginary parts. That means I will be getting x squared minus y squared as my real part, and minus 2xyi, the minus 2xy will be my imaginary part. Then now, when I do comparison, right, so x squared minus y squared is 10. That is the first equation where I compare the real part, and when I compare the imaginary part, okay, since both are negative, then I will ignore the negative. That means I will be getting 4 square root 6 equals to negative 2x. Sorry, I should get, okay, I will get 2xy equals to 4 square root 6 because both sides are negative. So then from here, I can further simplify. So I will divide the whole equation by 2. So then I will get the y as a subject as well. So it means that y is going to be 2 square root 6 over x. This is my second equation. So now, substitute second equation into first equation. It will be x squared minus square of the y equals to 10. Then from here, you'll be getting x squared minus square of 2 is 4. Square of square root 6 is 6. So 4 times 6, you'll be getting 24 over x squared that equals to 10. So now the whole equation you need to multiply by x squared. So it will be x degree 4 minus 24 equals to 10x squared. Okay, so from here, rearrange it, then you will get x squared, x degree 4 minus 10x squared minus 24 equals to 0. And now, factorize this. Instead of x squared, right, the quadratic equation, you just change the x in the quadratic equation into x squared. So which means here I will be getting x squared minus 12 and x squared plus 2. So now, x squared minus 12 equals to 0, or x squared plus 2 equals to 0, which means your x squared is 12, right? Or x equals to plus minus square root 12. So the square root 12 is same as square root of 4 times 3, which is 2 square root 3. Therefore, here is going to be plus minus 2 square root 3. Now, when x squared plus 2 equals to 0, that means your x squared is negative 2. So, in the definition of complex numbers, these a and b or x and y are real, okay? Real. When real means that square of the value won't be negative. That means this can be ignored or it must be omitted. Okay, so now we got 2x. So what to do is just substitute into the y from the second equation. So now from second equation, your y is 2 square root 6 over x. So when x equals to 2 square root 3, your y is going to be 2 square root 6 over 2 square root 3. So which is 2 square root 2, because a 6 is 3 times 2. Okay, and same goes to x goes to negative 2 square root 3. So the y is going to be 2 square root 6 over negative 2 square root 3, which is negative 2 square root 2. So now I will be getting 2 square root of u. That will be, don't forget, our answer equals to x minus yi. Okay, so it will be x means 2 square root 3 minus yi. So 2 square root 2i. And another one is negative 2 square root 3 minus yi. So minus minus is a plus. Plus 2 square root 2i. So that's the solution of this square roots of a complex number. Okay, next question 6a. Prove that cosecant 2 theta minus cot 2 theta equivalent to tangent theta. Okay, so I will start from the left hand side because it has two terms, then we can simplify it. Cosec 2 theta is basically 1 over sine 2 theta. Cot 2 theta is cos 2 theta over sine 2 theta. Okay, but then when you look at the answer here, it is just tangent 1 theta. So later I need to change my sine 2 theta or cos 2 theta into just 1 theta. So first of all, I will make it the same denominator first. It will be 1 minus cos 2 theta over sine 2 theta here. Alright, and then now we use a formula. So for the cos 2 theta here, we have three forms. So cos 2a is 2 cos squared a minus 1, or 1 minus 2 sine squared a, or cos squared a minus sine squared a. Since this is 1 minus cos 2, that means I have to use the second formula because the 1 is on the right side. Then when I move the cos 2a to the right side, it becomes negative, which means cos 2a is 1 minus 2 sine squared a. Then this cos 2a move to the right side, and the negative 2 sine squared a move to the other side. That means I will be getting 1 minus cos 2a equals to 2 sine squared a. Okay, so then now when you compare, our theta now is the a, which means on the numerator I will be getting 2 sine squared theta. Then the sine 2 theta, we have another formula, which is sine 2a is 2 sine a cos a. That means now it will be 2 sine theta cos theta. So from here, the 2 will be cancelled off. Then degree 1 of sine theta in the numerator will be simplified with the sine theta in the denominator. So at last, we will be getting sine theta over cos theta, which is tangent theta. Okay, so this is the solution of part A. B, hence means use the previous answer. Show that this integration is half ln 2. So when you look at the question here, cos 2 theta minus cot 2 theta. So it's exactly the same. That means I will just integrate tangent theta. So then integration of pi over 4 to pi over 3 cosec 2 theta minus cot 2 theta d theta. It will be the integration of tangent theta. So to integrate tangent theta, we need to change to the definition of tangent theta, which is the sine theta over cos theta. Okay, this is the only method to integrate tangent theta. So then after that, we need to apply ln. We apply ln here because the degree of the denominator is 1. So integrate f prime x over fx dx, it will be ln fx plus c. So when we when we differentiate cos theta, it will be negative sine theta. Okay, but then when you refer back to the original question, it is positive sine theta in the numerator. Therefore, to eliminate this negative due to the formula of the ln, I have to times another minus outside. So at last, you will be getting negative ln cos theta. And then my limits will be from my pi over 4 to pi over 3. Then now, I will just leave my minus outside. Then replace the theta by pi over 3 first. You will be getting ln cos pi over 3 minus ln cos pi over 4. So the cos pi over 3 is basically half. So this is ln half. And then cos pi over 4 is 1 over square root 2. Okay, so now let's see. You want to prove that it is half ln 2. So there's no negative here. What I need to do here is I will just write this equals to negative ln half plus ln 1 over square root 2. And then from here, I will, because we need to get the ln 2 over here, right? So then this ln half is basically ln 2 power negative 1 plus ln 2 power negative half, because square root is power half, right? And the 2 is at the bottom here in the denominator, therefore it's negative degree. Then now we use the formula. Ln a power b is b ln a. So now you are given left side, you just need to bring down the b and you'll be getting a simpler form. So then you'll be getting negative ln 2 plus negative half ln 2. So this is ln 2 minus half ln 2. So 1 ln 2 minus half ln 2, at last you'll be getting half ln 2. So that is our solution here. Okay, so this is the solution for question 6b. Okay, for question number 7, a curve is such that the gradient of a general point with coordinates xy proportional to y over square root x plus 1. The curve passes through the points with coordinates 0, 1, and 3e. By setting up and solving a differential equation, find the equation of the curve expressing y in terms of x. Okay, so gradient is basically dy dx. So now I will write dy over dx proportional to y over square root of x plus 1. So then from here, since this is proportional, then I will change to equal sign times a constant there. So it becomes ky over square root of x plus 1. Okay, or you can simplify this into just ky over square root of x plus 1. So this is the setting up of differential equation. And now next step is to solve. So when you need to solve, when you look at the y here, that means dy is the numerator, therefore the y must be moved to the left side. So I will get 1 over y dy that equals to 1 over square root of x plus 1. This dx will be moved to the other side. And don't forget to integrate both sides. This is the separable variables. So for the right hand side, I will move up the square root. So it will be x plus 1 to the power of negative half. Okay, and for the left hand side, to integrate 1 over y, it will be ln, because differentiate y is 1. So I will just get ln y. For the right hand side, okay, there's a k here, so miss out the k. I have to integrate using integration of ax plus b to the power of n dx. Then the answer is ax plus b to the power of n plus 1 over n plus 1. And don't forget to differentiate ax plus b to get a. After that, plus c. So that is the integration. So what we need to do here is just apply the formula, rewrite the function, the degree you plus 1. So minus half plus 1 is going to be half. Then divided by half, and differentiate x plus 1 is 1, followed by plus c. Then now I will simplify. So k divided by half is basically move up the half. It becomes 2. So 2k. Degree half of x plus 1, it becomes square root of x plus 1. Then plus c. Here is ln y. Okay, now to get the solution, firstly we have to replace 0, 1 or 3e. So I will replace 0, 1 first. So now 0, 1 at this point, which means the x is 0, the y is 1. So I will get ln 1 equals to 2k square root of 0 plus 1 plus c. So that means here ln 1 is 0. Okay, on the left side, this is 0. Then I will be getting negative 2k square root 1 is 1, so equals to c. Okay, this is my first equation. Then now I have to use the second points to get the second equation, because we need to find the k and c, two unknowns. So second point is 3e. So at 3, e, that means x is 3, y is e. So again, you substitute into this solution. So I will be getting ln e equals to 2k square root 3 plus 1 is 4, then plus c. So the left hand side, okay, the left hand side ln e is 1. Right hand side first term, square root 4 is 2. 2 times 2, you get 4k plus c. So this will be the second equation. I substitute first equation into second equation. So 1 equals to 4k. The c is negative 2k. That means here I will be getting 2k is 1. Therefore, k is half. Okay, and then from the first equation, my c is negative 2k, which means it will be negative 1. So at last, right, because you need to get the y as a subject in your solution. So now, after this, I will just substitute everything into this solution. So then I will be getting ln y equals to 2k. Okay, look at here. This 2k is basically 1. Okay, because 2k is 1. So I will just replace it by 1. Then square root x plus 1. So I will just direct write square root x plus 1. After that, followed by plus c. So the plus c is minus 1, because the c is minus 1. So now to get the y as a subject, we need to eliminate the ln. So take e both sides, because we have this formula. E ln a is a. So when I take e both sides, e ln y is e square root x plus 1 minus 1. So at last, my y is exponential of x, exponential of square root x plus 1 minus 1. So this is my solution. Okay, next question, number 8. The equation of a curve is y equals to exponential negative 5x tangent squared x, whereby the x is defined from minus half pi to half pi. Find the x coordinates of the stationary points. Okay, so more than 1 point here. Give your answer equal to 3 decimal places where appropriate. So now, For stationary points, we need to differentiate, okay, dy dx, and let it be 0. So the y is e negative 5x, tangent square x. So now the dy dx, since there are two terms here, okay, multiplication of two terms, we need to apply the products rule. So d over dx uv, that is u dv dx plus v du over dx. So now our u is the exponential. So your du dx, to differentiate exponential function, you just need to rewrite the whole exponential function, and then you differentiate the power of e. So when you differentiate minus 5x, the answer is minus 5. And then now the v is tangent square x. This tangent square x is same as square of tangent x. So to differentiate this kind of function, we need to apply the power rule. This is what we call as power rule. Power rule is to differentiate fx to the power of n. It will be n fx to the power of n minus 1, then f prime x. Okay, which means now your n is 2. So my dv dx is, bring now the 2, rewrite the tangent, degree minus 1, so it becomes 1. And now you differentiate the tangent x. Differentiate tangent x is secant square x. So my answer is going to be 2 tangent x secant square x. That is my dv dx. Okay, so now for my dy dx, it will be u dv dx, so exponential negative 5x, 2 tangent x secant square x plus v du dx. So tangent square x together with the exponential, negative 5 exponential. So tangent square x multiply with negative 5 exponential negative 5x. Alright, so then from here, I simplify first by factorizing the common term. So I notice that the common term is basically exponential, and then I have the tangent x. Okay, so I will factorize exponential together with the tangent x. Then I will be getting 2 secant square x from the first term, and then the second term will be negative 5 tangent 1x because I have taken out the tangent x. Okay, so now stationary points means dy dx equals to 0. So which means 0 is exponential 5x, negative 5x, tangent x, then multiply with the whole square bracket. So now we know that exponential cannot be 0. Oh, just for information, when you have multiplication of few terms equals to 0 means that any one of the terms might be 0. Okay, which means now when I consider exponential, well, you know that exponential cannot be 0, but then the tangent x might be 0, or 2 secant square x minus 5 tangent x might be 0. Okay, so when tangent x equals to 0, let's look at the tangent graph. And now let's see the question first. The question is from minus half pi to half pi. So this is going to be, okay, this is the graph. Here is 2 pi, here is pi, here is half pi. Okay, so since your graph is from, your x is from minus half pi to half pi, that means we will just look at this part and here. Okay, obviously it will be just at 0. This is our 0. Therefore, x equals to 0. Okay, because of the interval. So then for the next solution, I have to apply another identity. The identity is 1 plus tangent square x equals to secant square x. That means that here is going to be 2 bracket 1 plus tangent square x minus 5 tangent x, that equals to 0. Then now when we do expansion, it will be 2 tangent square x minus 5 tangent x, then plus 2 equals to 0. And this is a quadratic equation. Now we can factorize this into two linear factors. So the first factor will be tangent x minus 2. Second factor will be 2 tangent x minus 1 equals to 0. So now tangent x equals to 2, or 2 tangent x, okay, minus 1 equals to 0, which means tangent x equals to half. So now to solve this, since both tangents are positive, that means we could just get the first quadrant angle. So now look at the limits here. It is from minus half pi to half pi. That means you have to leave your answer in radians. Okay, so for the first one, you'll be getting 1.107, and the second value, which means x is inverse tangent half, then you'll be getting 0.464. Okay, so then let's look at the question. You have to give your answer correct to 3 decimal places where appropriate. Therefore, the final answer x will be 0, 1.107, and 0.464. So that will be the solution of this question. Okay, next question, number 9. Express fx in partial fractions. So let me copy the function first. Before you proceed, it's important for you to check whether this is proper or improper rational function. So the highest degree of the numerator is 2. Highest degree of the x in the numerator is 2. But for the denominator, highest degree of x is 3. That means this is proper rational function. Therefore, we can just direct apply the partial fractions. Now, then next step is look at the factor in the denominator. The first one is linear factor, so 2 plus x, and the second one is quadratic factor, but we can't factorize this. That means this is 3 plus x squared. Now your numerator is a constant for the first rational function, and the second one will be linear function, which is bx plus c. Okay, because the degree of the x in the numerator must be always 1 less than the degree of the denominator. So by looking at this, the next step is going to be getting the same denominator as in the left hand side. So which means for the first term on the right side, I already have 2 plus x, then you need to multiply with 3 plus x squared. Okay, same goes to the bx plus c. Then you need to multiply with 2 plus x. Okay, now since all functions have the same denominator, that means we can just ignore all the denominators and write down the numerators. So it will be 14 minus 3x plus 2x squared equals to a multiplied with 3 plus x squared plus bx plus c multiplied with 2 plus x. So now, to get the unknowns, I will let the linear factor be 0. So x plus 2 equals to 0. That means x is minus 2. So you substitute this minus 2 into the whole equation in the previous step. Then I will be getting 14 minus 3 bracket negative 2 plus 2 bracket negative 2 squared. So I will get a bracket 3 plus negative 2 squared. Then the left hand side will be 28. Right hand side will be 7a. Therefore, the a is 4. Now, since we only have one linear factor, then you can't let this factor be 0 because your x squared will be -3. So there's no solution for that. So then now you can just substitute any x values to get the other two unknowns, but the easiest way is just let the x be 0. Okay, so when you let x be 0, obviously the left hand side is 14 because the other two terms will be 0 due to the x. Then I will get a bracket 3 squared plus, not 3 squared, sorry, just 3 because 3 plus x squared. Then plus, when the x be 0, the b times 0 is 0. So c brackets 2 plus 0 is 2. Okay, then now replace the a by 4. So 14 is 12 plus 2c. Therefore, 2c is 2. Hence, your c is 1. And then now, I will let x be 1. So when you let x be 1, 14 minus 3 times 1 plus 2 times 1 squared, it will be a bracket 3 plus 1, 4. So 1 times b is b. Then the c will be replaced by 1. Okay, so from here, my a will be replaced by 4. I will replace directly. Then multiply with 2 plus 1 is 3. So then left hand side is 13. 4 times 4, 16. Then plus 3b plus 3. That means 3b is -6. Hence, the b is going to be -2. So after you have found the ABC, just rewrite your partial fractions. Okay, so then your fx equals to 14 minus 3x plus 2x squared over 2 plus x multiply with 3 plus x squared. This is going to be, the a is 4. Okay, the b is -2. Then the c is 1. So I will write plus minus 2x plus 1 over 3 plus x squared. So that is these are the partial fractions. Okay, next, hence obtain the expansion of fx in ascending powers of x up to and including the term in x squared. So now my fx is 4 over 2 plus x plus -2x plus 1 over 3 plus x squared. So this is going to be 4 bracket 2 plus x to the power of -1 plus -2x plus 1 times 3 plus x squared to the power of -1. Okay, so for your information, for this binomial expansion, since it is -1 degree, right, then we have to use this formula, 1 plus x degree n. It will be 1 plus nx plus n times n minus 1 over 2 factorial x squared plus the rest of the terms because we just need up to x squared. So, but then there is a rule for you to use this formula, which is here must be 1 and this must be plus. Okay, so here both also plus. The first term on the, this -2x plus 1, we don't need to expand because it's degree 1. So then what you need to do is just to convert the 2 to be 1 and 3 into 1. Okay, so need to convert these two. So to convert it, you just factorize the 2. Then I will get 1 plus x over 2. The whole term degree -1 plus -2x plus 1. Factorize the 3. So you will get 1 plus x squared over 3 degree of -1. So then from here, bring in the power -1. Okay, so -1 bring in, and this also same. So I will be getting 4 times 2 power -1, 1 plus x over 2 to the power of -1, plus -2 plus 1, then 3 to the power of -1, 1 plus x squared over 3 to the power of negative 1. Then from here, 4 times 2 power negative 1 is basically 2. Okay, and now we can do the binomial expansion using this formula up to x squared. So then from here, I will be getting 1 plus n. The n is minus 1. The x is x over 2. Okay, plus n, the n minus 1 over 2 factorial. After that, x over 2 squared. That is my first expansion. And then my second expansion is going to be plus negative 2x plus 1. This 3 power negative 1 is 1 over 3. Okay, so I will just write in front. So this is plus 1 over 3. Then I multiply with this expansion. So it will be 1 plus n is minus 1. The x now becomes x squared over 3. Then plus n minus 1, so over 2 factorial. Then x squared over 3 squared. Okay. Then we just need to do expansion or simplify. Not expansion, simplify first. So now, when you simplify the multiplication of all of this, right, you will be getting 1 minus x over 2 plus x squared over 4. And the next one, I just rewrite these two terms and simplify the terms inside the square brackets. So simplify all these terms. Okay, basically this term no need to consider because it's exceeding x degree 2. I just need to simplify up to here. So which means it will be 1 minus x squared over 3. Then plus dot dot dot. Right. So then my expansion, further expansion, just expand all of this. Then I will get 2 minus x plus x squared over 2. Then plus, okay, here I will do expansion. The 1 over 3 will be remain first. So negative 2x times 1, it will be negative 2x plus 1. Okay, sorry, negative 2x plus 1 multiplied by 1. It will be negative 2x plus 1. Then this negative 2x, when you multiply by x squared, is already exceeding x squared. So this 1 will be multiplied with negative x squared over 3. Okay, then now from here, I will do expansion again. So 2 minus x plus x squared over 2. The 1 over 3 multiplied with negative 2x, it will be negative 2 over 3x. 1 over 3 times x times 1, it will be plus 1 over 3. So 1 over 3 times negative x squared over 3, it will be negative x squared over 9. So at last, you will be getting 2 plus 1 over 3, which is 7 over 3. Okay, and then the next is minus 1x minus 2 over 3x. That means you'll be getting minus 5 over 3x. Then x squared over 2 minus x squared over 9. It will be plus 7 over 18 x squared. So that is our binomial expansion up to x squared. Okay, now let's move on to question number 10. The diagram shows a trapezium ABCD with AD equals to BC. So AD equals to BC, both are R. AB equals to 2R. So here is 2R. Alright, the acute angle BAD and ABC are equal. Both equal to X. Okay, here X. Circular arcs of radius R with centers A and B meet at M. This is the M. The midpoints of AB. Okay. A, given that the sum of the areas of the shaded sectors is 90% of the area of the trapezium. Show that X satisfies the equation. Okay. Now, Okay, sum of the areas of the shaded sectors. So which means now I need to find. Okay, so for the area of the shaded region, okay, I will write here sum of the areas of the shaded region or of the shaded sectors. Now it will be, because there are two here, so 2 times the area of the shaded region or area of the sector is actually half r squared d theta, half r squared theta. Let's say this is theta, this is r. So now you just need to change the theta into x. So I will get r square x, which means this is r square x. Now I need to find what is my area of the trapezium. So for your information, let's say this is a trapezium. Here is A, this is B, this is C. So the area is half A plus B times C. So obviously from the diagram here, the DC, we need to find what is DC. The AB is found. Then I need to find what is the height here. Okay, so I will let the length here, the value here be F, the points here be F. So now I will redraw. This is M, this is F. Okay, here is X, this is B, here is C, this is D. So this is R. Here is R. To R. Okay, so now from here, our AM, right, is the arc length of the AMD. So the AM is X, is R. Okay, so from here, right, given AB is 2R, so AB is 2R. Now I need to find what is my, okay, let me check. I need to find what is my DF. Okay, or I need to find what is my DC. DC and DF. So now I will refer to triangle ADF. Okay, so triangle ADF. This is R, here is X. So now my DF, okay, is the opposite side of the X, and the R is a hypotenuse. So opposite and hypotenuse, that means this is sine. So I will write sine X equals to DF over R. Therefore, my DF is R sine X. I found the DF. And then I need to find my DC. Okay, I need to find my DC. So this DC is basically 2 FM. Okay, when you look at the diagram. So DC is 2 FM. So now I need to find what is my AF. Okay, because I know that AM is R. I need to find what is my AF so that I can find the FM. So I will use cos to find my cos X to find my AF. So cos X equals to AF over R. Therefore, my AF is R cos X. So now my DC, okay, which is here, right, here is FM, that means this is another FM, so it's 2 FM. And then the FM is same as, okay, here, the FM is same as AM minus AF. Okay, so it will be AM minus AF. So the AM is R. The AF we have just solved, R cos X. So then now from here I have found my BC, found my DF. So area of trapezium equals to half of AB plus DC times DF. Okay, so half AB is 2R. DC, when you do expansion, this is basically 2R minus 2R cos X. So I will get 2R minus 2R cos X. Then my DF is R sin X. Okay, so from here, the 2 will be cancelled off first with the half, right? That means you will be getting R plus R, so 2R minus R cos X multiply with R sin X. Then now the R can be taken out. Okay, so I will get, this is R squared bracket 2 minus cos X sin X. Now, we have found the area of trapezium and area of the sector, shaded sector. And now it's mentioned that it is, the area of the sector is 90% of the area of trapezium, and you need to get this. Okay, so I will continue here. So which means the R square X, okay, which is the area of the sector, is 90% of this result. So no need to put bracket, just rewrite everything. R square 2 minus cos X times sin X. So obviously the R squared can be cancelled off from both sides. Then now, at last, you are getting X equals to 0.9 brackets 2 minus cos X times sin X. Okay, so this is the solution. So part B, verify by calculation that X lies between 0.5 and 0.7. So I will rearrange this. So X minus 0.9 brackets 2 minus cos X sin X equals to 0. So I will let Fx be the left hand side. Now replace the X by 0.5. And calculate this using radians mode. Then you'll be getting 0.0157, which is greater than 0. And f of 0.7, it will be 0.7 minus 0.9 times 2 minus cos 0.7, then sine 0.7. So this is going to be negative 0.0161, less than 0. So just write, since f 0.5 is greater than 0 and f 0.7 is less than 0, there is a sign change. Hence, X lies between 0.5 and 0.7. Okay, so that is how we prove the X lies between a number, between two values. So this is by using sign change rule. Okay, next, show that if a sequence of values in the interval x between 0 and half pi given by the iterative formula converges, it converges to the root of the equation in part A, which means now you have to start from this iteration formula and prove until this expression in part A. Okay, so firstly, we ignore all the subscripts. So it will be x equals to cos inverse 2 minus x over 0.9 sine x. Then now, when you look at the answer, the solution or the expression in the part A, I need 0.9 times 2 minus cos x, then multiply with sine x. So which means now we shouldn't leave the inverse cos anymore. So you should write cos x, move the inverse cos to the left side. Cos x equals to 2 minus x over 0.9 sine x. Then now get the x over 0.9 sine x as a subject. So which means I will just rearrange. So x over 0.9 sine x equals to 2 minus cos x. Then the minus 9 cos sine x will be moved up. Okay, and then when you compare to the answer in the A, we just need to rearrange the terms. So that is the solution. Okay, D, use this iterative formula to determine the x correct to 2 decimal places. Give the results of each iteration to 4 decimal places. So rewrite the formula. Two minus xn over 0.9 sine xn. Right, so from the previous calculation, from the part B, we know that the x lies between 0.5 and 0.7. So you can let the x not be 0.5 or 0.7 or the middle value, which is 0.6. So I will use 0.6. So now let x not be 0.6. That means I will be getting x1, which is inverse cos 2 minus 0.6 over 0.9 sine 0.6. Then this is going to be 0.6106. Remember to use radians mode in this calculation. Then x2. Okay, so now your final answer, 2 decimal places. So make sure you get 2 same decimal places. Right, otherwise you have to continue. So from here we have to continue for the next step. Then this is going to be 0.6151. Alright, so then here 0.61 on in the x1 and 0.61 in the x2. But then our final answer depends on the next digit. Since this is 5, therefore I will just write my x is approximate to 0.62. So that is the approximated root. Okay, now next question, 11. With respect to the origin O, the points A and B have position vectors OA and OB. Show that OA equals to OB. That means this is the length. And use a scalar product to calculate the angle AOB in degrees. So now, OA is 2i minus j, so 2 minus 1. Then OB is j minus 2. J minus 2k, which means 0i, 1j minus 2k. Okay, it is 3-dimensional vector. That means for the OA, I have to change. It cannot be 2-dimensional vector. It will be 2 minus 1, 0, because 0k. So now your OA is magnitude of OA, which is square root of 2 squared plus minus 1 squared plus 0 squared, which is square root 5. So OB is square root of 0 squared plus 1 square plus negative 2 squared, which is square root 5. So obviously OA same as OB, both equal length. So to get the angle AOB, so AOB, let's say the angle is theta. So let angle AOB is theta. Okay, so then OA dot OB equals to magnitude OA, magnitude OB cos theta. So then OA dot OB, I will just write 2 minus 1, 0 dot 0, 1, negative 2 equals to square root 5 times square root 5 cos theta. So for the scalar products formula, you just multiply each of these components and plus. So I will get 2 times 0 plus negative 1 times 1 plus 0 times negative 2. Then square root 5 is a 5 followed by cos theta. So obviously for the left hand side it will be minus 1. Okay, then from here your cos theta is negative 1 over 5. That means your theta is inverse cos of negative 1 over 5. Then you will be getting 101.5 degrees. So that is the angle AOB. Okay, next part. The midpoint AB is M. The points P on the line through O and M is such that PA ratio to OA is square root 7 ratio to 1. Find the possible position vectors of P. So now, okay, I need to find the midpoints of AB, which is the M. So for your information, this is A, this is B. Okay, let's say just an example, or probably I use back the previous diagram. Here AB. This is B, here is A. So this is your M. Okay, I know that the points of the coordinates of A will be 2, minus 1, 0. The B is 0, 1, negative 2. So 2, minus 1, 0. And this is 0, 1, negative 2. So I know that my M is with coordinates of 0 plus 2 over 2 because it's midpoint, 1 plus negative 1 over 2, and then negative 2 plus 0 over 2. Then it will be, okay, probably you can just write down the A is with coordinates, and then the B with coordinates. Then it will be having coordinates of 1, 0, negative 1. Therefore, we found the OM vector. So that is 1, 0, negative 1. Now, since your P is on the line through O, that means now I need to find what is my OP. Okay, so P is on the line through O. And now from here, alright, through O and M, through O and M. Okay, then I have to find my direction vector. So from here, the line is basically A plus TB. So now the A is the O. Okay, so I will just write plus TOM because it's through OM. So OM, this is OM. So the direction which is the B, okay, the direction vector in the line is OM. So this is going to be T times 1, 0, negative 1. And since P is on the line, that means your OP, the vector OP, is T0 minus T. Okay, so any points on the line will be having the R vector, the R position vector. So then from here, what you need to do here is basically you need to find P. Okay, now we need to use this ratio. So before you need to get this ratio, you have to find the vectors PA and get the OA first. OA is given already. So now vector PA is OA minus OP. So your OA is given in the previous part, which is 2 minus 1, 0. So here is going to be 2 minus 1, 0 minus OP we had just found in the previous step. Then from here is going to be 2 minus T minus 1, 0 minus minus T means positive T. Okay, and now when you look at the question here, it is PA. PA means this is the length, magnitude of the vector PA. So now I need to find the magnitude of vector PA. This is same as PA. That is going to be square root of square of the first component plus square of second component plus square of third component. So this is 4 minus 4t plus t squared. So the second term is plus 1, last term is t squared. So from here, at last, I will be getting 2t squared minus 4t plus 5. Okay, so from here, I will start using the given ratio. So the length of PA ratio to OA is square root 7 to 1. So then PA over OA is square root 7 to 1. That means PA is square root 7 of OA. So the PA is already found. The OA we have found in the previous parts, which is square root 5. So from here, I will just ignore the square root. Okay, the right side you can just combine to be square root 35. So you just ignore it. Then I will be getting 2t squared minus 4t plus 5 equals to 35. Which means 2t squared minus 4t minus 30 equals to 0. Then I will divide the whole equation by 2. That will be t squared minus 2t minus 15 equals to 0. And this can be simplified, or this can be factorized into t plus 3 and t minus 5 equals to 0. Hence, your t will be minus 3 and positive 5. Now, the question is asking for position vectors of P. Therefore, now your OP is T0 minus T. So now, when T equals to minus 3, my OP is T0 minus T. Okay, so minus 3, 0 minus negative 3. Then it will be negative 3, 0, 3. But when the t equals to 5, my OP is going to be 5, 0 minus 5. Okay, so these are the two these are the two position vectors of the points P. So with this, we have solved the question. Right? Okay, so with this, we have come to the end of the video. Thank you for watching. Please subscribe to the channel if you think that the videos are useful for you and you enjoy the videos very much. Okay, and also recommend it to your friends. Don't forget to stay tuned for more upcoming videos. Thank you. Bye.